This came about from an idea, a throwaway line, one of the Zoom meetings, and in the half hour before the formal Zoom meeting started, we were chatting. Anyway, Greg was telling us that the guys were working on using the WS2811 module, and they were trying to work out how to use the 2811. Now, I'd never really come across the 2811 chip at that point, so I did a wee bit of a dive into it. And I'd already done a wee bit about NeoPixels, but not enough to maybe do what I'm about to do. But now I feel that we've got enough information that we can make a sensible half hour, 40-minute presentation out it, and that people will learn a wee bit. Now, Davey mentions NeoPixels in his LED presentation, and there's a link to the LED presentation. The URL at the top there, if you cut and paste that into your browser, it'll take you straight to the WSAG YouTube group. Or, given we're all living in the 21st century, there's a QR code there. And if you point your phone or your QR code reader at it, it'll take you straight to Davey's LED presentation. And in the LED presentation, he mentions NeoPixels in the way by, but it's really just a cursory mention of them. So this presentation today is a wee bit of a deeper dive into these things, including how they work and some of the pitfalls and stuff like that. When I say NeoPixels, I mean something that belongs to the World Semiconductor 2810 series, the WS28 somethings. As you can see, there's half a dozen versions. There's also the SK Pine 6812, which is exactly equivalent to the WS2812. And the WS6812 is that little white thing at the bottom there. That's what most people consider a NeoPixel. But there's more to it than that. The 2811 is a small outline 8-pin DIP chip. No LEDs, just a little 8-pin chip. The 2814 is a 12-pin chip. The other three, the 12, the 13 and the 15, are chips that include the LEDs on board. The 2812 is the most common one. The 2813 is the same as a 2812, 3 colours of LED, except for it's got 6 pins instead of 4. Right, now what the extra pins are for you will see as we move on. And the 2815 is the SMD chip, 5050, 6 pins, and that's 6 pins because it's got 4 LEDs, red, green, blue and white, so that you can put white from the white LED on the NeoPixel along with red, green, blue or any other colour so that you can mix with a white palette. The reason that we use red, green and blue against that is when you mix those 3 colours on a dark background, you can make any colour up to and including white. But on printers, the paper's already white, so they use cyan, magenta and yellow, because that way you can mix those 3 colours in any colour all the way down to black, which is why printer ink colours are not the same as the colours on a monitor or on a LED. And your 2812 or your 2815 is that little square thing, 5mm square. You can see there's 3 or 4 patches of LED and there's a little chip on it. And also at the bottom there you'll see the typical NeoPixel strip. Those elongated copper pads, you can cut those with a pair of scissors and you can have a strip that's 5 LEDs long or 17 LEDs long or however many. You can buy this stuff by the yard. The base NeoPixels are 4-pin LED devices, 4-pin through-hole LED devices. You get them with big thick diffuse covers, with shallow diffuse covers, with gin clear covers, always for 4 wires. Supply, ground, data in and data out. The one that's by far the most common now is the surface mount 50/50. Now that 50/50 means it's 5.0 millimeters by 5.0 millimeters. It's got 4 pins on it, and they come with either a white bezel or a black bezel. And you can see you can buy them in all sorts of variations. You can also get 3535 surface mount NeoPixels. Now that's 3.5 millimeters by 3.5 millimeters. And they're useful for a reason that I'll explain in a wee while. They're essentially just a scaled down version of it. I'm taking these images, by the way, from the Adafruit site. What you see in the left is what you see with the naked eye. What you see in the right is an enhanced decapped where somebody scraped the top layer off. You can see the little chip. You can see the various LEDs. If you look carefully, the one in the left has got 4 electrical connections. The one on the right is the 6-pin one. And another thing to notice that not everybody notices is that in the top right of the left-hand image, there's a wee corner chipped off, a little bezel on the corner of the NeoPixel. This thing's square. There's 4 ways you can put it down. And there's certainly 2 ways that you can put it down with the connections. So you have to get it the right way around. And that's what that wee triangular chip off the corner's for, so that you can orient it the right way around. And if you look at the other one, the little chip is in the bottom left for orienting it the right way around. So having told you what's in the family, I better tell you what's not in the family. The 2801 was the previous generation before the 2810 series. And they're great, they work as well, but they're not NeoPixels. They're not interchangeable with NeoPixels. Dot stars are a different thing entirely. The LPDs are different. And you get analogue strips that look like a NeoPixel strip, but it's just red, green and blue LEDs. None of these work the same way as NeoPixels. And I'm not decrying any of them. They're all useful in their own ways, but they're not NeoPixels, and that's kind of what I'm here to talk about today. If you go out and buy one this afternoon or tomorrow, you'll probably get 2812B NeoPixels. The reason for this being that the 2812B has an internal copper valence, which gives it better heat performance, means it can draw more current, which means it can put more light out, and it's got protection against, it says here reverse polarity, but a bigger problem with these things isn't reverse polarity, but it's overshoot, where your power supply, apparently they particularly dislike bench power supplies. Because sometimes a bench power supply, if you put it on to 5 volts, it will shoot up to 5.5, 5.7 volts, and then down to 4.7, and then back up to 5.1, and then down, and it will settle after a couple of oscillations. And that bounce, that overshoot can kill a NeoPixel. So if you're killing NeoPixels and you're using a mains power supply, that might be the reason that you're doing it. So I'm just sort of throwing that one in. When you buy them, this is what you get. There's £1 there for reference to give you the size of things. That squared paper is 5mm squared. And as you can see, those are 50/50 NeoPixels, because you can see that they're 5mm square. And the one on the right, you can see the little bezel, the chip off the top left-hand corner. They come in a tape, and the bevel's always put in the one direction. The smaller one, there's the smaller one there. We've talked in the past on this channel about the Raspberry Pi 2040 Zeros. That's a Raspberry Pi 2040 Zero. And if you look closely between the 2 buttons, there's a wee white rectangular blob. That's a NeoPixel. And this is really, really useful. The RP2040 is a great controller for controlling these things. If you use an Arduino Uno or an Arduino Nano, it's fine, it'll get them to work. But it's only got 32K of memory. And if you start putting more and more and more NeoPixels on, then you run out of that 32K pretty quickly. Because you're going to need a big sequence. If you've only got one or two NeoPixels, then you've only got half a dozen or a dozen possible states. If you've got 25 NeoPixels, then suddenly you've got thousands of possible states of various LEDs being on and off at the same time. And so you need a great big memory to hold all those states. So you're probably going to want a NeoPixel controller that's got a bit of memory in it. And the 2040 is great for that. It also runs quicker. I'll explain later on that the faster the controller's running, the better for NeoPixels. You can't run a NeoPixel on a 1 MHz controller. It has to be at least 12 MHz, which is an Uno. Faster than that is better. Slower than that, it won't work for a reason that I'll explain. But because the RP2040 has got a NeoPixel on it, that NeoPixel is dedicated. It's on line GP16 of the 2040. So I built my circuit and I put the circuit on, let's say, pin 18 of the 2040 to drive whatever it is that I'm driving out in the planet with my NeoPixels. But before I do it, to get the software to work, I just say to the software, instead of going to pin 18, go to pin 16. And when I send it to pin 16, the NeoPixel on the board does its thing. And so I can see that the software's working, independent of the hardware. And once I've got the software working, then the hardware's a separate problem, and it's an easier problem to fix. If I'm not wondering, wait a minute, is there something wrong with my code, or is there something wrong with my wiring? That way I've separated the problem. Another thing, before I put NeoPixels into circuits, I use some of these. Adafruit make a lot of NeoPixel hardware, and it's not very expensive. Particularly if you buy it from some of the UK suppliers, Pi Hut or Pi Moroni, or some of these people that are wee shops that are set up to sell maker electronics. There's one there, it's 8 NeoPixels on a board. The decoupling capacitors have been added. The input snubbing resistor has been added. The whole circuit's there. It's been built. It's been tested. So it's dead easy for me to use that to check out a NeoPixel circuit before I start plugging it into the NeoPixel circuit that's on the layout or that's on the board that I'm working with. That's a great way of checking out the NeoPixels. There's another one. That's 7 in a blob. I've actually got one of these in the living room now. My wife has got a big salt, a pillar of salt, a Himalayan salt can thing that had a little tea light underneath it. You take the tea light out and put one of those underneath it, and this thing can change colour all day. Very, very simple decoration. There's another one. 16 LEDs in a circle this time. And they do a great big one of those where I think it's 48 LEDs in a circle. And they also do segments so that you can make, quarter turns or eighth turns and make any shape that you want out of the straight ones plus the curves and all that. If you want to put NeoPixels round about a sign, or round about a mirror, or whatever. Or you can buy them in that format. That format has got two uses. First of all, as it stands, it's a NeoPixel matrix, and you can light them up and display figures and shapes and lettering on them or whatever you want to do. But equally well, as you can see, they've been scored and they've been routed out, so you can snap them off into individual NeoPixels and use them as single NeoPixels. A single NeoPixel has got a couple of uses beyond being a little light source that I'll explain as we go further on. And I already mentioned the strips. There's the strips. You buy those from our friends in China for a couple of pounds and you cut them to length. As you can see, looking at the bottom one there, you can see the connectors and where you snip between them. And every time you snip between them, it doesn't affect. You don't have to worry about addresses or any of that stuff. These things are non-addressable. And I'll explain that when I get into working out how they work in about 3 slides from now. The last variation, we've just been through Christmas. And if you've got a Christmas tree outside or you want to decorate the outside of your house, you can get NeoPixels on weatherized, rubberized lengths like that. These things click into each other. You can get them 1 metre, 3 metre, 5 metre. They take a lot of electricity, obviously, if they're going to be bright. They're IP6 or IP5 compatible. And I bought one just to play with. I haven't used it for anything. So, getting on to how they work. There's the data sheet for the 2812. These started being made by World Semi, but they're now made by about a dozen other companies. Everybody's jumped on the bandwagon, and there's nothing proprietary in this circuit. I'm about to show you how they work, and there's nothing in there that is a trade secret, and so all sorts of people are making clones of them. And some of them are close clones, and some of them are not so close clones. Different sizes, different shapes, different form factors. A lot of them have different phases. So instead of red, green, blue, you get red, blue, green, red, all that sort of thing. But you have to sometimes worry if you buy these and they're clones, you may have to experiment to find out which colour's red, which one's green, and which one's blue. And that's the data sheet for the NeoPixel, that's the data sheet for the chip. And this gets me back to where I joined this conversation, speaking to Greg in Brisbane about this. This chip has got a red, green and blue output, a data input and a data output, just like the NeoPixel. It's also got a power supply and ground, just like the NeoPixel, 5 volts. And it's got a set, and that set, you pull that high or low to make it high speed or low speed NeoPixel. And just when you're thinking about buying some of these chips, it turns out that our friends in the East do them, and they do them in bulk. That's £9.59 for a lot, and the lot is 100 pieces. So that's 9.5 pence per board. And the board comes with the chip, with the decoupling capacitor, and with the series resistor that you need. All pre-wired. All you need is a soldering iron and some wire. The 4 connections at the top are, as you can see, red, green and blue, plus a plus. I'll explain that in a second. And at the bottom there's 4 connections as well, but it's a wee bit sneaky. On one side there's 5 volts, and the other side there's ground. And those have got a load of vias on them each, so they're stapled through from both sides of the board. The 5 volts is the 5 volts, and on both sides of the board the ground is the ground. But on one side of the board it's DI for data in, and on the other side of the board it's DO for data out. So that's how you daisy chain them. You solder the input side to one side of the board, and then you solder the output side to the other side of the board. It's the same on a lot of decoders. If you're putting a decoder onto a DCC decoder into a local, only this thing is much bigger and much easier to handle than a DCC decoder, so it's much easier to solder. So when I started preparing this, I looked up the price again, and I thought, oh, the price has gone down. It's now 8 pence each. But then I looked more closely, and that says 50 pieces. It says 50 pieces, but there's 100 chips in that board. So I don't know what we're going to get if you actually buy that for £7.99. I lashed out my £6.50 because it was £6.50 when I saw it, when I was talking to Greg about it. And there's what came in the post. 100 of them, all on a big block, and you had to crack them apart, snip them apart to get at them. I'd been telling Davey about it, so he bagged a few of them off me. So he's away with a strip of them, and he then started and put together a demo on using them here. Now this demo was on this channel very recently, and it's using them, as you can see, to drive LEDs, individual LEDs, and also to drive motors, servos, animations, sound controllers, all that good stuff. So again, there's the link to Davey's presentation on the YouTube channel, and there's the QR code again to get to Davey's presentation on the YouTube channel. It's much more succinct than mine. His is only, I think it's about 12 or 15 minutes, and it's basically much less waffle and much less theory than I'm going into here. It's more or less how can you use one of these and what can you do with it. Moving on to the data sheet. The data sheet for the 2811 chip tells me that it needs 5 volts for the chip, and the data in and out is to be 5 volts. 5 volts will drive the 3 LEDs, but if you want to go to 12 volts, you can put 3 groups of 3 LEDs in. Now I can see where that would work. If, for example, you've got a level crossing lights, for example, where all the lights go at the same time, you could quite happily put multiple LEDs there because they're all going to flash at the same time anyway. Yep. And having looked at it and examined some more specs, the chip needs 5 volts, the data needs to be 5 volts. The official ones are 12 volt tolerant. I've seen them that claim to be 20 volt tolerant. Your mileage may vary there. I don't think I would risk 20 volts. Although if I had 18 volts for a DCC, for example, you might want to rectify that and use it as a supply for these because they take a bit of current. If you think about it, each of these LEDs can take up to 20 milliamps. So that's 60 milliamps per NeoPixel. If you get 15 of those, that's an amp. So these things can draw a bit of juice, so you have to be a wee bit aware of that. If you've got the 2 speeds, one speed's 72 frames per second, which means they can update 72 times per second. And you can drive 512 pixels that way. Or you can slow it down to 36 frames per second. Now 36 frames per second is still out with your persistence of vision. You're not going to see it flickering at 36 FPS. Certainly I don't. But at that point you can drive 1,000 of the NeoPixels. And each channel you can have 255 levels of red, 255 levels of green, 255 levels of blue. That all adds up to 16.7 million different colours that you can have. There are strict timing requirements. Now this is really important. These things work by a pulse that is to be a certain width. I'm about to go into the theory of that. But that pulse has to be there, and it has to be a certain width at a certain time. Things like Raspberry Pis and ESP32s and PCs, for example, have got multiple threads all running at the same time. So if you've got a circuit that's driving a string of NeoPixels, and it's halfway through putting the pulses out, and the Wi-Fi suddenly needs attention, or the screen needs a refresh, and the chip has to abandon you to go and do the screen refresh, then you'll lose the NeoPixel frame. So for that reason, things like Raspberry Pis, PCs, ESP32s are much more difficult to use with the the NeoPixels. It doesn't preclude them altogether, but it means you have to pay much more attention if you're using something that's got interrupts on it or DMA transfers on it or any kind of hang-up available. So at this point, we're going to start from the beginning and show you how they work. When you start learning digital electronics, the first thing you learn is combinational logic, which is AND gates and OR gates and NAND gates and NOT gates and all that good stuff. And then the next thing you learn is sequential logic, which is where you take gates and you attach their outputs back to their inputs, and suddenly strange things happen. And this is one of the simplest gates that you can make in sequential logic. It's called a D-type or data flip-flop. And what happens there is, if there's a 1 on the input, when the clock goes down, that 1 gets transferred to the output. And it holds a single bit of memory. And that's about the simplest thing you can do in sequential electronics. So what they use them for mostly is this. That's a 5-bit static memory. So if I put 5 ones or zeros on the inputs there, then when the clock arrives, those 5 ones and zeros get transferred to the outputs. And that way you can hold a number, and it can keep that number through time, which the rest of combinational logic can't do. But that's not the only way that you can use a D-type flip-flop. Here's a circuit that's got the same 5 flip-flops, but this time the output of number 1 is connected to the input of number 2, and the output of 2 is connected to the input of 3, and so on, all the way along. This is called a shift register. So when the clock first arrives, whatever's on the first input gets transferred to the output of the first one. And when the next clock pulse arrives, whatever's in the input this time gets transferred to the output. But at the same time, the clock arrives at the second one. So whatever's on the output of the first one gets transferred on to the next one. And as the clock pulses keep arriving, so whatever's in the input gets transferred along to the output. So what we have here is a circuit that takes serial data in and produces parallel data out. And that's what a shift register is. It's a fundamental building block. If you're going to do any kind of electronic design, and certainly any kind of digital design, you become very familiar with the shift register very, very early on. So if I take 3 8-bit shift registers and give each of them a digital to analog converter, then I can clock in a whole bunch of ones and zeros. And once they're all clocked in, if I just hold that, then the ones and zeros will get converted into parallel by the shift registers. The parallel will get read by the digital to analog converters, and that'll give me the voltage to drive the LED. And so the LED will be driven more or less depending on what the input to the shift registers is. The one trick about it is that I've only got one wire for data in and one wire for data out. So there's a little bit of circuitry at the input to take the data in signal and convert it to data for the shift registers and clock. And there's a similar but opposite one at the other side, which takes the data and the clock and converts it back to the data output that the next NeoPixel can read. Now that output one's important for a reason that I'll explain later. Apart from recombining them, it stiffens it up. It makes sure the timing's correct. It makes sure the pulse is the right height and the right shape, which means that the pulses that are coming out your microcontroller aren't getting degraded as they go along the NeoPixel chain. Every NeoPixel straightens up the data as it sends it to its neighbour. So the data that comes out the last NeoPixel is fresher than the data that you put in the front end. Now this little bit of logic at the beginning and end is nothing more complicated than a Morse code reader. The bits that go into the NeoPixel are either a da for a 1 or a dit for a 0. And the only other thing it understands is if it sees more than 50 microseconds of nothing, then I'm lost. I'm waiting for data, a reset, and I go back to being where I was this morning when I first got power. Now that 0.8 microseconds and 0.4 microseconds is not negotiable. If you let that go on too long, the NeoPixels will just ignore it. They'll eventually go into a reset, but that really has to be done properly. If you look at it on the scope, there's what you see. And if you look at it on the scope while the NeoPixels are changing, then that dances like the Aurora Borealis. It's actually very pretty to watch. That there is 25, I think, NeoPixels in a chain. And that happens in less than a quarter of a millisecond. That pulse for 25 of these is quarter of a millisecond. And if I zoom out on my scope, you see there's the quarter of a millisecond, and it's every 12 milliseconds. And that every 12 milliseconds is why there's a 72 frames per second frame rate, because I can squeeze 1024 of those NeoPixel data into that half millisecond between the two pulses. And that timing is critical. And because that timing is critical, somebody's got to write code for that. But we live in the 21st century, and you can bet your bottom dollar that somebody's already written the code for that. There's a library. There's code already written for it that you can just plug in. There's code written for the Arduino. There's code written for the PIC chips. There's code written for JAL. There's code written for the CircuitPython and MicroPython and for Atmels and for STMs and for MPS40s and everything. Anything you want to talk about, there's already a library written for it. The machine that I'm sitting in front of, I went into its Arduino, show me the software libraries that you've got, and I said, just give me the libraries that include the word NeoPixel. And I got 40 libraries. And not only that, but that 40 libraries doesn't include the libraries that don't include the word NeoPixel. There's umpteen libraries that are for WS2812B and WS2812. And so I bet you there's more like 60 or 80 libraries that are suitable for this. Now, as I said earlier, Adafruit make a lot of really nice, reliable, steady hardware for this stuff. So I tend to use their nice, reliable, steady software for it. And if you look, the third one down there is the Adafruit NeoPixel, which I have got installed in this machine. And I use that if I'm using NeoPixels with an Arduino. But there are hundreds of options here for doing all sorts of clever things with your NeoPixels. And it's worth going in there and having a wee read just to see some of the things. Snake lights and 7-segment displays with a NeoPixel and all sorts of groovy stuff that you can do with them. You simply include the NeoPixel, and then after that, there's what your code looks like. If you take the time to go and look at Davy's presentation on the 2812 boards, then you'll see he's got the same sort of code in there. It's very, very simple. Once you've included the library, you use words like colour wipe, theatre chase, rainbow for 10 milliseconds. The commands are very, very simple, and it's suck it and see. You can just try this stuff in a REPL loop. Try it, see what happens, change it, see what happens. Dead simple. In the Thonies, in the MicroPython and CircuitPython, it's equally easy. As you can see, set red, green, blue to 100, 0, 0. 255 is the maximum. So 100 is just less than half red. No green, no blue, so that's red lead. Green is 0, 100, 0. Blue is 0, 0, 100. Yellow is 100, 100. You can see where this stuff really isn't hard to do. But you need a controller. So at this point you have to choose your controller. And I'm dividing them up into two different types of controller. First of all, there's direct controllers. Here's a list that I just came up with off the top of my head. You can control these, as I've said earlier, by Arduinos, by PICs, by Picos, by Digistamps, by ESPs. Xiaos are Chinese microcontrollers that a lot of people are starting to use. If you're going to use ESP32, Raspberry Pi or PC, you have to be careful, as I already explained, because of the timing issues. But there are libraries for those, and there are libraries for those that take care of the vagaries of having to use interrupts or DMA transfers or whatever. So for that reason, if you're using one of the more complicated ones, you have to make sure that the NeoPixel library that you're going to use for your ESP32, for example, is compatible with the library you're going to be using for your display or your touch controller or your Wi-Fi, because you don't want them both using interrupts at the same time. They've got to each give each other space. So it is doable, but it's doable with care. And if you want to do it, take care. So what does it look like? There's an Arduino Uno, 16 megahertz Atmel 328, as we're all aware. So 16 megahertz is plenty of speed for driving these. There's 16 NeoPixels in a ring. 3 wires, as you can see, a red wire, a black wire and a grey wire. Red wire, 5 volts. Black wire, 0 volts. Grey wire goes to, I think it's digital I/O6 in this case. 3 batteries make up 12 volts. The 12 volts supplies the Arduino supplies the NeoPixels, and if we press the go button on this, old chubby fingers comes in and away it goes. I had huge difficulty getting this to work in terms of getting it to show. The NeoPixels are really bright, and if I turn down the exposure to where you see the colours in detail on the NeoPixels, you can't see anything else. It's all darkened out by the exposure being so low. And I wanted the exposure to let you see that it was just an Arduino and a ring of LEDs and a battery. But because I was doing that, the NeoPixels get just a wee bit bright. But that's a direct controller, and you can do those. You can set those up all over your layout. You can set them up all over your house. Do what you like. But there's also indirect control. And that is that Arduino, or that RP2040, or that Pico. It's got one wire driving all the NeoPixels. So it's got all these other pins. So you could, for example, drive one of those other pins from a TOTI. And when the TOTI comes active, because a loco has entered the section, then that starts the NeoPixels that are driving your level crossing lights, as a for instance. So these are indirect controllers that will control your controller. These are things that you can use to drive the other inputs on your Arduino or your Pico or your RP2040 or whatever it is. Analog level. You could, for example, put a potentiometer on, and the potentiometer drives the speed at which the traffic lights change on a piece of road. If you've got traffic lights and you want them in demo mode where they're all flashing, but you want them to change very more subtly, you could do that. Or you could put an analog level on that controls the brightness, so that during the day, all your traffic lights and all your signals round about your layout are all bright when there's daylight and you want to see them. But after dark or in the evening, you don't want all these bright lights on, so you just turn a knob and you could turn all the NeoPixels down at the same time. So they're all up at 200 for daylight. You turn the knob and take them down to 100 or 80 or 60 for how dark it is, depending on where you want to set the mood. Or you could drive them from CAN bus. It only takes one wire to drive the RP2040, and CAN bus will give you, I think it's 16 wires coming off a controller at the minute. SPI, Fermata off a PC, whatever you want to do. If you're using the 2811, you don't have to use red, green and blue. Davey's already pointed out that you can use red plus yellow plus green, and that's a set of traffic lights, red, amber and green. If you use red plus yellow, that's a set of level crossing lights. If you use red plus green, that's a shunt limit indicator on a siding. You can use white for headlights, red for side lights or brake lights, yellow for indicators for a car. Do that with the little microlit sleds for putting light into vehicles and houses and all that stuff. Police, ambulance, fire engine, red, blue and white, flashing light, very, very simple. Or if you put a great big bunch of these and just used cold white to warm white and made it go from light to dark, you could simulate clouds overhead just by changing the amount of white light that's coming through. You could have dappled daylight coming down on top of your layout. Lots and lots and lots of possibles. You can use one controller for each module. That's a simple one. That's the one that Davey explained first, whereby you simply use the 2811 module and 3 LEDs. In this case, a red, an amber and a green. You can optionally put a controller in from a TOTI or a switch on the mimic panel or a detector that detects some other animation running. Or you could put an output there so that when these things are running, it's driving the sound controller just as well. You can control it from the PC, and I've also put the option whereby you can add external power. You could put 5 volts on there if you need to control this externally, and it'll drive both the RP0 and the NeoPixel. That's very, very similar, only it's a set of level crossing lights, and I'm using the daisy chaining of the NeoPixels. Notice you don't need to put anything on the end. The top end of the chain, the last output, doesn't need a resistor or a terminator or any of that stuff. You just leave it floating in the breeze. I'm using my one controller. Let's put more on it. There's a set of traffic lights, north, east, south and west, with 4 lights, each one with a red, amber and green. And I'm not scratching the surface of what that little 2040 can do. That scratches the surface of what that 2040 can do. There's a layout that's got 4 sets of traffic lights on it, 2 level crossings, a siding with a shunt indicator on it, some block working 4 aspect lights, a couple of them with feathers on, and again you can control them all for these wee boards that are 7p a pop. The controller's £1, the boards are 7p a pop. There must be nearly £5 in electronics on that board, plus the LEDs obviously. This is practically free. Now I mentioned the individual NeoPixels, and they're useful for a reason I'm about to explain. This is one of the little wrinkles about these things. Imagine I've got a layout that's got a set of traffic lights at one end and a set of traffic lights at the other end, and it's 5 meters long. Because of the high frequency that's involved in this, there's a limit of about 2 meters. If you go above about 2 meters, your pulses start to get a bit rounded, you start to get overshoot, you start to get undershoot, it starts to get a bit bleh. And so 2 meters is about the limit. If you have got a long run like that at 5 meters, then what you can do is simply put a couple of NeoPixels in that don't do anything. Remember that output circuit I said? It cleans the pulse up, reshapes it, revolts it, makes it clean again. So it goes 1.7 meters, then it gets cleaned up by NP5, and then it goes again, and then it gets cleaned up again by NP6, and then it goes again. And so the pulse that NP7 sees is a clean version of what came out of NP4. I have to write my code so that I'll just go back, instead of having 8 NeoPixels from 1 to 8, it's now got 10 from 1 to 10, but 5 and 6 don't get colours on them. Of course, if I put colours on them, then I could use those as indicators. I could use those to indicate something else, to calibrate something. I could use those under the board to let me see what's happening. I could use those in a mimic panel, depending on what I want to do. Or I could just bury them. Or I could put them in a building just for a change to just use them if there's something in the spot. But occasionally you might want to use NeoPixels, not as NeoPixels, but as NeoPixel repeaters. I'm sure that while I'm talking, you've been looking at this and thinking, I've got 1 or 2 applications for that. So I thought for about 5 minutes and came up with 1 or 2 applications for that. Traffic lights, railway signals, vehicle lights, building lights, indoors. Television simulator, they're great for that. If you get a tiny wee NeoPixel and make it flash random colours, you get random colours coming out of it, and you change the speed so you get random flashes or random colours, and then you put it in a building with a frosted window. It looks like there's a television in that building rattling away. Yep, and it's cost you 70p. Street lights, there's an idea. How about sodium lights that come on yellow and then become white later on in the evening? The sky, as I say, you could dapple the sky, you can make clouds scud across the sky, or the sky become bright blue whenever it feels like it. There's lots of options here. Level crossings, routine. Firebox, routine. Welders, we've already got the welder that flashes white, cold white 3 or 4 times, and then you get a red glow. You could do that with 1 LED here with a controller. Coach lighting, again, coach lighting that works day and night. Coach lighting that when it's dark outside, you've got a nice warm white, sort of homely looking light inside the coach, but during the day you've got a bright enough light that you can see the detail inside the coach. Shop signage, roundabout cinemas, roundabout fairground attractions. Put them in the mimic panels, put them as indicator lights. There's 1,000 things that you can do with these. Davey's already explained that there's a lots of uses for these that aren't to do with lights, to do with motors, servos, animations, and triggering other devices like sound players and so on. And I've already plugged that presentation a couple of times, but I'm plugging it again shamelessly because it's a useful quarter an hour of your time to go and watch that. Couple of hints and tips. This is the boring part of this, but we're very nearly finished, so please hang with me. You need a microcontroller. You can't just buy NeoPixels and put electricity in them and expect to see light. Doesn't work. Boards fitted with a NeoPixel. If you get that little RP2040's got a NeoPixel in the back. The cheap yellow display, the CYD boards. Davey did a thing last year about making a touch panel display for EasyBus, and that used a cheap yellow display board which costs a £5 from our friends in the East. I bought one recently for something else which I've recently been showing Davey, and I'm no doubt it'll turn up in a presentation near here very soon. But the CYD has got a NeoPixel in the back, and again, dead useful if you want to debug your NeoPixel code. If there's a NeoPixel on the board, then you can debug it locally before you start putting it out to the circuit. Because of that time and being strict, NeoPixels might not be the best solution for what you're trying to do, right? They need a fast, single-threaded micro, in my opinion. You need at least 16 megahertz. 32 megahertz is better. The ESPs and all that now run at 75 megahertz. The top-end PICs run at 72 megahertz. The one thing you also have to worry about is dividers. you're looking at a frequency that's zero point 0.8 of a microsecond and 0.4 of a microsecond. If your lines can only go up and down in 0.7 microseconds, you ain't going to be able to drive that. And even if it's 0.113 microseconds, you're not going to be able to get 0.4 microseconds out of holding it up for 1.3 microseconds. You can have 3.9 or you can have 5.2. You can't get the 4 sort of thing. So you have to sometimes think about the frequency that your microcontroller's running at. Different suppliers, as I say, one supplier's red, might be another supplier's green or blue. So it's worth taking them and build a very, very simple circuit just to control it in one NeoPixel to see how it works and play with it, make it work and get used to the colours and get used to the brightness, because they're bloody bright things. The new ones in particular will have your eye out. If you say, oh, 255, I'll have some of that. And the next thing, it's like when you look at somebody welding, you've got to go into the other room and make a coffee or something because you can't see anymore. So you'll get used to the brightness by playing with it. They're not good for persistence of vision. You know, the thing where you wave your hand and it leaves dots in space, because they're already flashing. So if you move them along, you're flashing them on and off and they're already flashing. It looks kind of grainy and kind of horrible. So don't do that with them. Diffusers are good. You can buy diffusing plastic from our friends in the East. Really useful for making one NeoPixel look like a single point of light rather than making it look like three wee closely aligned LEDs. You can also buy NeoPixels that have got diffusers on them for a penny extra. As you use more and more NeoPixels, you need more and more RAM, more and more memory in your controller. You can imagine a big layout that's got 50, 60 of these on it. It would be absolute rubbish if they all changed at exactly the same time. So you want to have maybe 150, 200 phases where there's different sets of lights on. Like Christmas lights, you don't want them all changing at the same time. And so you need a lot of RAM for that. And as I say, for every 15 NeoPixels, you need to budget an amp of power supply. So it might be a good idea to run a separate power supply. You ain't getting an amp off your Arduino. You'll get 20 milliamps off an Arduino if you're lucky, and at that point you'll maybe pop a pin in the Arduino. So I wouldn't risk it. And also the timing. If you go above, maybe 100 of these things, you maybe start running into timing issues, and you maybe have to turn the speed down to the 32 or is it 36 frames per second. Lastly, the downstream thing. If the nth pixel dies, if I've got a stream of 20 of these and the 13th one drops dead, blows its fuse, then the 14th one, 15th and 6th, all the way up, the rest are all dead. It's like Christmas lights. Remember the old-fashioned Christmas lights in the tree and having to twist the bulbs to find which... Yeah, well, this is a bit like that. If the nth NeoPixel dies, then from then on up, it's black, which makes it very easy to debug. But it's a thing to be aware of, that these things are all in series, they're all in sequence. So lastly, some hints and tips. Because of that overshoot problem, always connect the negative before you connect anything else. So you connect the minus wire, the ground, and then you connect the data and the plus. You don't connect the plus first and then the data. Bad things will happen, you will regret that. You sometimes need a big capacitor, but that's becoming less and less of a problem. And as you see, nearly all the boards that you buy from China have got the capacitor already on them, and they've got the series resistor already on them. So that takes away the thing about the decoupling thing. Another thing to think about is if I've got, as I say, 15 of these as an amp, and because of the nature of how they work, they go from being in a certain position to being in another position. They all turn on, they all turn off, some turn on, some turn off. So the current that is being drawn from the supply is stepping up and stepping down and stepping up and stepping down. Not every supply likes that. Battery supplies don't like stepped draw like that. They sometimes get a bit warm if you do that. Power supplies sometimes ring. And for that reason, it's a good idea to put a big capacitor across your NeoPixel chain. And that way the big capacitor's holding a charge. And when the NeoPixels start drawing extra current, the capacitor supplies it. And the capacitor starts slowly discharging and your supply starts recharging the capacitor, and it smooths out the draw, the stepping up and down that the current draw is doing because of these LEDs all coming on and off in sequences. You'll get away with a few NeoPixels. Well, you just saw me driving 16 of them in a ring out of an Arduino. But then I had the wick turned down to 10 or 15 on them to try and get the exposure to work. If I tried to run that full blast, it would probably blow that Arduino's pins. You know, you can get 60 milliamps on a single LED here, so you have to be really careful about it. And this kind of reiterates the same stuff over and over and over again that I've already said. If you're using a wall wart or a big battery, add a capacitor to stop the step current effect. You need a data resistor between the output of the data pin and the input to the first NeoPixel. Preferably put your resistor at the NeoPixel end of that connection. But again, if you're buying modern tapes or boards or that from China or from Adafruit or any of these people, there'll already be SMD components to do this work. But be aware of it, that if you're having trouble, this is the stuff you're checking, essentially. You don't need a terminator, I've already said that. And minimise the distance. A metre or two is usually no problem, but individual NeoPixels can act as repeaters. I just explained that one, whereby you can put a repeater in, not to give you light or to be useful, just to clean up the signal and make it better for the other side. They're static sensitive, so you've got to put your tinfoil hat on for them. My personal preference is my soldering iron is earthed via a 1 meg ohm resistor, and I use that. And as you know, I touch the soldering iron occasionally. The smell of chicken makes me feel comfortable and lets me know that I'm working properly, and that also earths my body down to the ground in the room. If you accidentally put power on your microcontroller and you haven't powered the NeoPixels, they will try and suck power through the data line. And so the NeoPixel strip will suddenly try to take all its power out of the pin of the microcontroller, but not the power pin of the microcontroller, out of the I/O pin of the microcontroller. And that'll probably blow the I/O pin of the microcontroller. So for that reason, it's better to power the NeoPixels before you power the microcontroller, or have the microcontroller come up and put all the pins that have got NeoPixels on. In fact, it's best practice for every microcontroller, irrespective of what you're doing with it. It's good practice that when it comes on, to make all of the pins inputs. Because if you put as the micro comes up and you put an output on, something's going to happen. Whatever that output's driving is going to actuate. And you don't want things actuating when the microcontroller's not in control. So it's good practice. Actually, most Atmels and PICs, when you switch them on, they do come up as inputs until you declare them as being outputs. But it's a good practice when you're writing code to write at the start of your program, make everything an input until you're all set up, and then give it half a second, delay 500, and then you know that all your electronics is stable, and then you apply the outputs and start sending ones and zeros out to your lights and your motors and your actuators and all that stuff. And that's good practice, and it's particularly good practice with NeoPixels, because if a pin comes up that's an output and the NeoPixel hasn't had energy yet, it'll try and take that power and it'll damage the controller. They're 5 volts and they need a 5 volt data line and a 5 volt power line. If you're using a 3.3 volt, you can use a level shifter. There's half a dozen different types of level shifter. I personally use the one that's a bi-directional level shifter, and it's made out of FET and a couple of 10k resistors. You can use the little level shifter boards. There's a couple of level shifter chips. Davey again has done a presentation on level shifters, and there's more than enough detail there. The other thing is, it doesn't need to be a bi-directional level shifter. It only has to be one directional, because you're only going from the micro to the NeoPixels. There's never data comes back from the NeoPixels to the micro, so it only has to be a very, very simple level shifter. The cheapest and easiest level shifter is an NPN transistor and a 1K collector resistor, but the only problem with that is that your ones have to become zeros and your zeros have to become ones, because it inverts the signal. But you know, if you're that cheap, then you can do that. Don't try, I'm just going to connect this up with crock clip wires to see if it works, because connecting and disconnecting crock clips can cause little sparks, and little sparks are overshoots and undershoots, and they will kill a NeoPixel. Much, much better to solder a wee wire on and then crock clip to the wire than to try and crock clip to the board. Please don't do that. And this is the golden rule for all of this stuff, is if you've got two separate circuits, they have to share a 0 volt line, they have to share a ground line, and share the ground line before you share anything else, or bad things will happen. And it won't be my fault, because it was the last thing I told you in this presentation. I've done all the damage I can do for this afternoon, so at that point I'm going to stop. And if anybody's got any thoughts, any comments, or any questions, now would be a good time to make your presence felt.